Hello? Hello? Hopefully nothing crashed.
Hi!
Alright, can everybody hear Kim and me correctly? Put a thumbs up if you can hear us.
I have thumbs up. I can hear you just fine. I am also going to go ahead and start my stream. Let me,
Alright, cool. Yes, got the thumbs up too. Thankfully, my computer fan is not absolutely eradicating the sound right now.
I am also live! Hi!
Hi!
Hi, everyone! Hi!
Alright, do we...
Syzygy, why don't you go first and say hi? You start your stream first, and then I will also say hi.
Alright, cool. Speeding at sea, it's me, Z. Hello, everybody. My name is Syzygy Altair, or just Z for short. I am a physics, engineering, aerospace, math, basically a science VTuber. But today I am going to be talking mainly about astrophysics, which is super cool because we're both astro nerds. So I stream only on YouTube. So it's really cool to, you know, be joining Kim on Twitch today.
Dude, the cross-platform collab. I've never done a cross-platform collab. It's so cool.
Woohoo! Woo woo! So I'm so glad to see all the Orbeez here. Kim, do you want to introduce yourself as well?
Yeah, hi, I'm Kim. I am an astronomer. I spent 2 or 3 years working at observatories in Hawaii, and now I'm on my way to grad school in astrophysics. And I know Z through keeping an eye on other physics and astronomy VTubers, and I love her physics content, and she invited me to do a collab where maybe we answer questions you guys submit, and that's what we're doing, and I am so excited for it. I am also here with my viewers, the Space Squad. So hi guys, it is good to see you. I'm glad you could make it. So the way that we set this up was for the last like 2 weeks, Z made a Google form where you guys could submit your questions to us. And now we're gonna get to answering them, and I'm very excited about it. So we kind of, like, as you said, you're also a lot of physics and engineering, which I am like no engineering. You've said that I'm a little bit more like observational, which, yeah, with experience at observatories, I'm very observational. I like astrobiology a lot.
Wait, Orbeez,
what other specialties,
cool?
like...
Oh, wait, I was
Sorry,
just
say
gonna
that again?
say, isn't it so cool that, like, Kim has worked at an observatory? Like, that is just so sick. Like...
2 of them.
And 2 of them! Double is better. It's so cool.
Yeah, and also I think it's very cool that our specialties are very different. So aside from like physics, engineering, you said you do astrophysics research. Did you mention that you do a lot of like galactic stuff? Do I remember that right?
Yes, that's correct. So I do mostly like galaxy research. I haven't really mentioned it at all, I think, just because I feel like it has really high doxing potential.
Yeah, I yap about space a ton on my streams, but I don't talk about my own research.
Yeah, I did recently release a paper. That was a few weeks ago, and that was super exciting. But yeah,
I saw that you had a publication party. That's huge. That's so exciting.
Oh, thank you. It was so much fun. We like spun like a giant wheel of doom. It was very intense.
That's awesome. I love it.
Well, I did want to
say...
Okay,
Yeah, go ahead.
Oh, I did want to say that when we sent out this form, honestly, I expected that we'd get, like, a handful of questions. We ended up getting, I think, a total of around 50 to 60 questions, which is insane. So thank you all-
Yeah, we have, like, 65.
Yeah, thank you all so much for submitting all the questions. In this slideshow, we only included the few, I think, like, up to, like, a few days ago. So if you don't see your question, like, don't hesitate to, like, put them in the Discord, either on my Discord or Kim's Discord. I've also linked Kim's Twitch in my YouTube channel chat, so definitely go check her out and go click the... you guys don't have subscribe, right? Is it like following or something?
Yeah, it's follow. Well, okay, subscribing on Twitch means you give them money. Following is our equivalent of subscribing, yeah.
Oh.
Yeah, and also I have a command in my chat, ! collab. If you guys use that, then it will take you to Z's YouTube so that you can subscribe to her.
Yay!
Do you want to get started on the questions?
Yeah, let's do it. Let's do it.
Okay. Sicko mode, let's go. Alright, I am going to the next slide. So you want to like alternate reading the questions, and then occasionally we might be like, actually, this is your question, not mine.
Yeah, let's do that. Let's do that.
Okay, so Shub asks, what would be a good sci-fi book that you'd recommend? I don't have. You answer first.
Okay, so I wrote down some answers in advance, but that actually kind of changed because today I went to a bookstore and I discovered many new sci-fi books that I could also recommend. Off the top of my head, I really love The Three Body Problem. That is one of my favorite sci-fi books of all time. Along with Project Hail Mary, which was written by the same guy who wrote The Martian. I actually think it's better than The Martian. Really, really, really great work. And then one more recommendation that I saw today at the bookstore was The Martian Chronicles, which is actually a collection of short stories as these astronauts arrive on a inhabited Mars. That's all I will say. I don't want to spoil too much. Yeah, Three Body
Yeah, you read way more fiction than I do. So I hardly read any fiction, and when I do, it's usually not really sci-fi. But my favorite book is this. Oh my god, it's ancient. Let me see if I can find it real quick. Hold on.
Oh, you were screen sharing, by the way.
Yep, that's the point. This book is so old that, you know how books have like printed on them, hard printed, how much they're supposed to sell for? And for this book it says 25 cents.
What?
Ignore the reviews. I think it's a really good book, actually. It's called Dark Dominion by David Duncan, and it's from published in 1954. But I enjoyed this book a lot. So that's probably the only one that I really have to recommend. When I was a teenager, I really liked this book series called The Comet's Curse. Has anybody heard of it? Z, have you heard of it?
No, I have not.
It's like, teenagers are the target audience, so I probably wouldn't enjoy it anymore. It's about this disease that like shows up on Earth, this virus, and it is completely lethal and there's no cure, but it only affects people under the age of 16. So they're like, how do we save humanity? So they put all these fucking teenagers on a spaceship and say, go colonize the universe.
Wait, this gives such like dystopian vibes. Oh my god.
Yeah, so those are the only answers I have to that question as well. Should we move on to the next one?
Yeah, I wrote down Dark Dominion. If I see it in there's an ancient bookstore, so if I see it, I will let you know.
Okay, yeah, I have 2 copies because it's such an ancient book and it hasn't been printed in so long that like both of my copies are completely falling apart.
Oh no.
Okay, next question. This one is for you to read.
All right, serious question time. What are both of your picks as the most interesting moon in the solar system that isn't Europa? And this question is from Metallic Medley. Do you want to go first, Kim?
This is targeted because I love Europa so much.
Wait, I love Europa too.
Okay, challenging question for both of us. Perfect. Okay, you go first.
Well, okay. Wait, so I am such a huge fan of the Europa Clipper, that whole thing, but I'd say other than that, I don't know why I'm glitching out so much, by the way. I'll probably figure that out in a second. I'd say Enceladus is a really close second. Yeah, my chat is also saying Enceladus. I think Titan,
I see that, yeah.
There's a helicopter mission that's planning to go to it soon that is also quite interesting.
Titan?
Yeah, to Titan.
Yeah.
And I think this is not as interesting, but I'm a huge fan of the moon Mimas. It looks like the Death Star from Star Wars, and apparently there's a lot of geological, glacial history and lore behind its big crater that I'm certainly not qualified to talk about, but yeah, I'd say Enceladus, Titan, and Mimas. What about you, Kim?
Okay, so I would also say Enceladus. But if you challenge me to say something that is not subsurface ocean possibilities, then I think I would also say Titan. And if you challenge me to pick something else, then I would probably say, and I can't do Triton because I love Triton, but that's because Neptune's moon Triton. That's because subsurface ocean possibility, so I can't say that. So then I guess I have two answers. So I think Mars moons are cooler than Mars itself. I really like Phobos and Deimos because they're so small, and soon, like 70 to 90 million years, one of them's gonna shatter and Mars is gonna have rings, which is super cool. And I think it's Phobos that is small enough and close enough that if you were standing on it, you could probably throw an object to Mars. So that, and
What?
also on the note of, honestly, doing the physics for that would be really cool. Also on the note of Saturn's moons being cool, Iapetus is very, very cool because it looks like you like open an Oreo, like half of it is completely white and the other half is very, very dark.
Yeah. No, my chat is also asking about Io. I think Io is also very cool. It's just there's no it's so active. It's just volcanoes, death. It's not an ideal landscape to be in.
Yeah, Io is very cool. I have never much entertained the idea of like a lander on Io because I feel like it would get smited very quickly.
Oh, it would last like an attosecond. Like it would not.
Oh, it'd be so funny.
Yeah. I think Enceladus, though, I've actually heard that they're developing robots, and I actually got to see these robots that are shaped like snakes that would be able to go underneath Enceladus and maybe navigate its structure underneath or even its subsurface ocean, which is so sick.
That'd be cool. Yeah, I would also say Enceladus. Yeah, short answer is Enceladus would be my second favorite moon. All right, should we go to the next question?
Yep, next up.
So from Dara Foxy, oh my god, I love this question. If you can send a probe to any physical body in the solar system, where would you send one? Money is not an issue, and the probe will arrive in 5 years, so no problem with time. Okay, I would like to answer this one first, if that's okay.
Yes.
Let me take a quick drink of water first, and then... Okay, so here's the thing. If you had submitted this question and said, money is not an issue, end of question, I would have a very different answer. However, you specified the probe will arrive in 5 years. So I'm going to exploit that and say we're going to the fucking Oort cloud.
Let's freaking go!
Yeah. I feel like it would be such a waste of an opportunity if I didn't exploit the hell out of that. But if time was not, if it was actually going to take the typical allotted, sensible, makes sense in the context of physics amount of time, probably just an Enceladus lander, and I'm thinking of Enceladus because the Enceladus orbit lander is a thing, or maybe Europa lander would be what I would want.
Yes, that would be so sick. For this question, okay, you were really smart by saying Oort cloud because I would totally also say that.
Yes!
But
except then it gets into an interesting question of, depending on your definition of the solar system, the Oort cloud is not in it. But we can make it work, it'll be fine.
It's okay, it'll be fine. I'd say... Okay, so I originally thought maybe Triton, because it was like Neptune's moon, it's like the furthest one out there, and it has potential cryovolcanoes. Otherwise, it would take us a really long time to get there. And then I also thought Enceladus. There's a very common theme in this stream, Orbeez.
That just means we have good taste.
Yeah, what can I say? We just know where we need to go.
Yeah. Thankfully, Enceladus, I don't know if it's actually going to happen, but the Planetary Science Decadal Survey identified an Enceladus orbit lander as a priority, right? So hopefully that happens sometime.
Wait, I did read that. Yeah, no. I'm actually stoked.
It would be awesome. I mean, even just having that security of something that has been widely accepted as what the priority should be for astrobiologically related future missions, I think that level of security is nice, even if it has zero funding so far.
Yeah, I think it'd be really cool to even just think about what that would look like. Because for Europa Clipper, for those of you who do not know, Europa Clipper is a spacecraft going to Jupiter's moon Europa. And it is going to be doing flybys of Europa. And one of the reasons for that is because of Jupiter's immense radiation and gravitational field, so it's not able to stay in orbit around Europa, and let alone even land on it. But it would be so cool to... I mean, Europa Clipper is equipped with the radar to penetrate through the ice, but, you know, like, going into the ocean is going to be super exciting.
I want to go swimming. Yeah. Okay, and then also, sorry, Z, I don't remember if you said this earlier in the stream, but I don't remember if I don't remember if either of us said it, so I want to emphasize that, as you said, we did get 65 questions. We will not get to all of them, but I'm excited for the ones we are going to get to.
Mm-hmm. Yeah,
and we'll do as many as we can.
Yeah.
Okay, should we go to the next one? I don't remember whose turn it is.
Yeah, I think
it's yours.
I think it's my turn to read. Yeah.
Yeah.
All right, so give me stuff, please. Okay, a very epic username. All right, well, they ask, are there any specific things you think astronomy in particular and science in general needs to be doing outreach-wise? Beyond the more generic, like, do more outreach, of course.
Do you have an answer to this?
Yeah, I can go first. So,
sure.
I was thinking of two things. I think with the rise of the internet, with social media, it's really easy for people to feel connected with one another and to share photos and to share astrophotography, to share recent science achievements. But one of the things that I think we need to keep doing, not saying that this is going away, but we need to keep doing, is having social skywatching events. Because I think having an intimate having like an intimate connection between like seeing something out of your own eyes through a telescope is a wholly different experience from looking at a photo on Instagram, clicking like, and scrolling to the next one. I think there's just something so profound about that. And in these social skywatching events, you are also promoting younger children, younger students, to be using the scientific method, because you're thinking, oh, what's that star up there? You're asking a research question, then you're developing a hypothesis, and then you're looking through the telescope to gather your data and results, and it's actually the scientific process being used in a social, fun setting, which is what makes social skywatching events so fun. Yeah, no, it would be very awesome to do that. I think the second thing that comes to mind is, I think when the Interstellar movie came out, there was so much discourse on bridging science and science fiction. I mean, they made the black hole with, like, Kip Thorne, for instance. I think it would be so cool if there was, like, another big movie like that a lot of people got nerded out about. I think Oppenheimer sort of did that, but, like, it wasn't really space, per se. It was also a little political, a little, like, more about, like, nuclear physics, I guess. But I think if another movie were to come out like that and spark that discourse again, that would be super cool outreach-wise. I don't know, Kim, what do you think?
Yeah. I like those answers. Those are a lot more fun than my answer. I'm going to keep my answer short because I don't really want to get super political, but I think that as astronomers doing outreach, it is more important now than ever and will continue to be very important that we conduct our astronomy and outreach ethically and mindfully.
Mm-hmm. Yes. Yeah, continuing
so that's... Mm-hmm. Yeah. Although, you know, the crazy thing about your answer is I still haven't seen either of those movies.
What? You haven't seen
Okay, I'm really uncultured. No! Yeah, so I really want to watch Interstellar pretty much entirely because of their black hole simulation, right? But I don't... It's like a 3-hour movie. I don't know if I have the attention span. And then Oppenheimer, like you said, it's pretty political, which is not really my thing.
I have to admit, Oppenheimer, I liked Barbie more than Oppenheimer.
Me too! Well, I haven't seen Oppenheimer, but I love Barbie.
Well, okay, Interstellar, though. Interstellar, it is a slow rise. It takes them, like, I don't know, like, an hour before they get to space. But that is shocking to me. All right. Your fans are called Space Squad, right? Space Squad, you have to bully Kim into watching Interstellar. This has to happen.
Yeah, that's fair. I should. I would like to.
Yeah.
They say we will. Okay, should we go on to the next one?
Yes. Oh, it's a rapid round next.
Okay, what do we start with?
Do we just want to read all the questions and like answer like really quickly?
Okay. You want to do it? I do the whole slide, you do the whole slide?
Yeah, sure. Let's do that.
Okay, answering quickly is really, really hard for me because I'm autistic, but I'll do my best. What's my favorite observatory? Theoretically, the 30-meter telescope, but that's not built yet. What was the first constellation you were able to find on your own? This is... Okay, you know, obviously there's the Ursa Major and Ursa Minor, but I have a little bit of an attachment to Pegasus because it's really, really easy to find. Ooh. It's a giant square. It's so easy. I love it. If you could explore one heavenly body in the solar system besides Earth, which would it be? Europa. Night sky of the northern or southern hemisphere. Wrong. Equator. Equator. I might be cheating, but equator. And have you ever wanted to rename a constellation? No, not really. I don't pay a lot of attention to constellations and asterisms.
Oh, when you said equator, I literally screamed.
Well, like, that's on Mauna Kea in Hawaii, we can see every asterism at some point in the year.
That is so sick.
Yeah, it's great.
Wow.
Alright, your turn.
My turn. Okay. What's your favorite observatory? I'd say it's about to be built, the LSST Rubin Space Telescope. What was the first constellation you were able to find your own? I think Orion was really easy for me. If you could explore one heavenly body in the solar system besides Earth, what would it be? I would also probably just say Europa, Lamau.
Yeah.
Night sky of the northern southern hemisphere. I'd say northern. Yeah. I'd say northern. I'm more familiar with those. I don't think I've actually seen the southern hemisphere that much. Have you ever wanted to rename a constellation? Not really, but okay, there are some constellations that are like 2 dots, and they were like, ah yes, it is telescopium. It looks like a telescope. Like... like, it could be something, like, sick, like, I don't know, like, okay, what's, like, why do we have a constellation for coffee? Like, a coffee cup or something? Or, I guess do we have a cup? We have Aquarius, the cupbearer.
I don't know, you can play Animal Crossing and make your own.
Wait, I literally, so I actually do have Animal Crossing, and I kid you not, like, Celeste and I are, like, besties, because Me
too! I love Celeste!
Yeah, I only spend time in the observatory.
That makes a lot of sense, yeah. That tracks.
Yeah. Corona Borealis is cup-shaped. It will now be renamed as Coffee Borealis.
Corona Borealis.
Yeah, let's see this.
Constellation.
Oh, wait, Kim, did you hear that there was a star that is going to explode in Corona Borealis, and they've been saying this for, like, a year?
No, I have not heard that, but a year is, like... Wait. You're gonna say it for another 50 million? Like...
Well, apparently it's going to explode. They said it would happen in, like, the next, like, month or so, and then they said that, like, 3 months ago. But if it explodes, it will actually be bright. That. Yeah.
Interesting. That would be exciting. I hope so, but also, it's kind of entertaining for it to just not do that. Alright, ready to move on?
Yes, let's go. Oh, round 2.
Round 2, okay.
So these will be mostly for you, Kim.
Oh, okay. Okay, exciting. Oh yeah, this one's definitely for me. Favorite and least favorite aspects about working at an observatory. Okay, the favorite aspect is exactly what you would expect. It's the science. The coolest thing that I got to do when I worked at JCMT was that I got to take data for the Event Horizon Telescope. So I was so happy I got to do that. That said, interferometry nights are insanely intense. Oh my god. They're just like nonstop go, go, go for like 6 to 8 hours. It's very stressful. And also, you know, your data is being synced up with all these other telescopes, so you're all like, so you kind of have this mindset of like, I hope I'm not the odd one out that causes this entire observation to fail.
No, wait, that's so cool though. What?
It was great. Yeah. So I took data for their 2023 and 2024 runs, but neither of those runs have been published yet because they're slow.
Wow, that
Maybe
is so
soon, though.
sick.
Yeah. Okay, and then least favorite aspect of working at an observatory? It's not really anything like observatory related. I think it's just related to, actually, okay. Sometimes, well, okay, funding related shit. JCMT, like many other observatories, has funding issues, so funding related shit gets really frustrating.
I see,
And then other than that, it's just like bureaucratic and administration related stuff that sucks at a lot of jobs.
Isn't it also quite stressful to get time at an observatory? Like, to organize the
Yeah, but
requests?
working as a telescope operator, that's not my problem. I'm
I
taking the
see.
data for the people that do time. Yeah. And then another thing that does suck about it is that sometimes, like, as a telescope operator, part of my job was when an error or fault came up in the night to fix it, enough so that we could continue observing for the rest of the night. And sometimes I would like, go into work at, like, 5, try to start observing, get a fault that was really, really dumb, spend 4 to 6 hours nonstop trying to troubleshoot it, and then get it working so I'd still have to work the remaining 6 hours of my shift. Those were the worst nights.
That's like almost like what? Like, that's like, that could be like 12 to 15 hours of continuous work.
My shifts were 14 hours, but unless I was troubleshooting a fault or doing interferometry, there was a lot of downtime.
Oh, wow. That's crazy. That must be a lot of work.
A little bit, but it's fun.
It's rewarding.
All right, next one.
All right.
I guess this one is also for me. So, Gimme Stuff wants to know what happens if you miss an observation at an observatory. Well, kind of 2 questions. Let me start with the first one. So observatories have 2 different methods of conducting their observations. 2 different, like, scheduling methods. There are schedule-based observatories, like the one that I worked part-time at, IRTF, was like that, where if you were granted time on that observatory, they tell you, okay, this day, this time, this is when we're taking your data. And maybe you have the option to go there in person, maybe you have the option to tune in remotely, maybe you have the option to tune in remotely and actually take your data yourself, and the telescope operator just supervises you. But if you get weathered out, then that's too bad. That was your allotted time slot, and you don't get another chance. What JCMT does is queue-based observing, where everybody who was granted time on that telescope for that, we used a semester system, so 2 every year. For that semester, all of their observations are added to a, like, query tool, and then based on the current weather conditions and what is in the sky right now, you observe what is the best option for what to observe right then. It's not a rigorous, like, observe this object at this time. So depending on which of those scenarios you're in, I think there's going to be different things that happen if you miss an observation. At JCMT, the only time that I would describe, like, missing an observation at JCMT was during interferometry, where we have this set, we have to be on this target at this time precisely to the second, and if you're late, then that's bad. However, if you miss an observation during interferometry, if you are late to it or miss it or whatever, you let your support astronomer know, and then they let the Event Horizon Telescope or whomever's data you're taking know, and then I think they just account for it in their reductions, that JCMT or whatever observatory you were at missed a little bit of this specific exposure. I hope that answers the question okay. I mean, like, it is very, very much like we want to rigorously do as much time on sky as possible. But working in a queue-based observing, in a queue-based observatory, there was never any, like, oh, you missed an observation, how are you going to amend it, or something like that. And how important is temperature during observation on a practical basis? The temperature of your dish and the air in your dome is very important, because it effectively causes, like, I think basically turbulence in the, like, air and atmosphere around your dish, which fucks with your light waves. So when we opened JCMT, we would always have to wait minimum 30 minutes for the dish and the dome to cool before we could start doing science. So actually quite important. Also, don't point it at the sun. Thankfully, JCMT works in the submillimeter, so if we do point it at the sun, it's not gonna like burn out our instruments, but it is gonna warm up our dish, which we don't want. Yeah, so I hope that's a good enough answer to that one. Z, why don't you start with this one? I think we can both answer this.
Yeah, so the question is from Give Me Stuff Please Okay, again.
Wait, sorry, Z, give me 1 second. I'm gonna make you be quiet for a second because my audio is having issues, but I know exactly how to fix it. It'll take like 2 seconds. All right, thank you, Lacris, for letting me know that. Discord. Okay, say something?
Testing.
Okay, yeah, you should be good now.
Okay, cool. So the question
All right, go ahead.
From Give Me Stuff Please Okay is what if any benefit is there for visible light astronomy versus infrared versus other wavelengths? So, okay, I think this is a cool question because I think I could take this from like a more astrophysics perspective, which is that different light tells us different things about a system. So let's say you're looking at a galaxy, right? You can look at the visible light, the stars, but there's a lot of dust and gas in a galaxy, right? So how can you sort of see through that? Well, you could do that by looking at other wavelengths. For instance, if you were to... Whoa! Whoa! Something's dropping on Kim!
Oh, yeah, when somebody uses an emoji in my chat, it gets thrown at me. There might also be some other slightly more disruptive things that happen in my model, like,
Oh my god! Oh, Kim! Are you okay?
Yeah, that happens. Yeah, oh yeah, also this one.
Oh my god, what is going on?
Yeah, they can stuff me in a locker like the nerd I am. I let my viewers do that too. So those are things.
Oh my god, now there's emojis everywhere. They're so fun. I love it.
Sorry, I interrupted. You were talking about dust and how to see it.
Yeah, so if you want to look at I can't even focus. Okay, wait, hold on. All right, lock in. What in the tarnation? So, if you want to look at the black hole of a galaxy, for instance, you could do that by looking at higher energy wavelengths like X-rays. And so different wavelengths of light can tell us different clues about a system. So one of the reasons why, for instance, the James Webb Space Telescope is looking at infrared is not only because it can look at specific parts of a galaxy, but because things that are further, how do I say this? Things that are more further back in time that we're looking at. It's so weird because space and time are connected. But things that we are looking further away, which means that they are further back in time, are redshifted to us. That means that their light appears to us stretched out, which means that it appears redder to us. So if you imagine, if we were to take a picture of a galaxy super far away and it would be a little bit red, we wouldn't want to look at it just by using the light that we see around us. We would sort of want to look at it through a reddish filter, because then it would look normal to us. So one of the reasons why the James Webb Space Telescope uses infrared wavelengths is not only A, to penetrate through the dust in specific systems, but also B, to look at these galaxies that are redder because they are some of the earliest galaxies in the universe, which is super smart. And I guess, Kim, you can also answer this question as well.
Yeah, so you did a really good job covering the physics and astronomy reasoning behind it. So rather than covering that part of it, I will cover a little bit more of the observational and instrumentation part of it. So to add a little bit more to the physics and astronomy side of it, I think there's benefit to observing every single wavelength because the entire electromagnetic spectrum is there. Objects emit light in and or reflect light, or both, in many wavelengths. It's not just limited to the visible, so we can get data by observing all of them. I think Z did a really good job explaining that. On the instrumentation and like observational side, there are pros and cons to them. For example, interferometry, which is used in the Event Horizon Telescope, it's basically where you kind connect multiple telescopes very, very precisely on an extremely precise time scale and have them observe the same object at the exact same time, at the exact same wavelength. Using a technique called interferometry, you can combine that data to effectively have observed it with a telescope with a diameter equivalent to the distance between the two telescopes that you used. Interferometry, however, is only really possible at present with longer wavelengths. We use it in radio, we use it a little bit in infrared and submillimeter. And then a con, for example, X-ray and gamma ray astronomy are both very, very cool and very exciting. However, those wavelengths are so energetic that if you are not careful, they are also prone to destroying the telescopes and instruments that we try to use to observe them with. So I think that's all I have to that.
Mm-hmm. Yeah, no, that's a great answer, and I think that really delves into the different use cases of these wavelengths as well, which is super cool, super smart.
Yeah, I think like one way to classify astronomy into subfields is by which part of the electromagnetic spectrum that you work in. And people work in pretty much all of them. We do manage to do science in pretty much all of them, but the techniques vary a lot between them, and in some it's harder than others.
Yep, exactly.
Should we go on to the next one?
Yep. Oh, it's round 3, I think? Astrophysics
Is it?
time. Yeah!
Astrophysics time. Perfect. All right, these are going to be more you, I think.
Oh, I think this first question might be both of us.
The first question's definitely a both of us, yeah.
Yeah, I put these two questions together because I thought they were very similar. So the first one is from Terrified, which is, would you guys mind telling us a little bit about some of your favorite equations and how to use them? And the second question is from Shifted Clock, which is, are there any equations in astrophysics or physics generally that you find particularly beautiful, elegant, or meaningful? Kim, do you want me to go first, or you can go first?
Yeah, you go first.
So, okay, I jotted down a ton, like, off the top of my head. So, wave equation, and basically every single partial differential equation. Incredibly
Oh god,
powerful
those scare
tools.
me.
Wait, they're so fun! They're so cool! And then I was thinking also, like, numerical methods, like the Runge-Kutta method. I don't know if I'm saying that right, actually.
Runge-Kutta?
Yeah, Runge-Kutta.
That's how my professor would say it. Yeah, Runge-Kutta.
Runge-Kutta, yeah.
Pretty close.
Pretty close. And then in astrophysics, the radius, temperature, luminosity relationship, which is like L equals 4 pi r squared sigma t to the 4. That one's really cool too. And in physics in general, I'd say top 2 are Maxwell equations and Lorentz transformations for special relativity. So that was a lot, but I have a lot of favorites, I guess. Yeah.
Yeah, let's pull Maxwell's equations up at the very least so we have a visual of those. I don't have nearly as many answers as you do. So I have 2 favorite equations. And they're both pretty basic answers, but I just think they're fun and simple and beautiful, and I love them. So one is just the formula for gravitation. F equals gmm over r squared. I love that shit. It's simple, it's beautiful, and also, like, gravity is important, and I love it, and I just think it's gorgeous. And then the other one is, it's on my jacket, actually. It's on my Super Kim VT jacket.
Wait, what? Let's see.
Do you want me to pull up a picture of it?
Yes.
Hold on, let me move this tab elsewhere to find this picture. Here, wait, actually. What am I screen sharing to you right now? Do you still see the PowerPoint?
Yeah, it's only the PowerPoint.
Okay, cool. Yeah, let me pull this up real quick. Hold on. Okay, yeah, so I have a custom jacket. Wait, hold on. I gotta find good pictures of it. Fuck it, I'm just gonna pull up my Discord. Actually, no, that's not gonna work because I'm screen sharing Chrome. Sorry, hold on. Please hold. I can find this. I have a custom painted leather jacket that... Here we go. This is a good picture that shows it. Yeah, here we go. Open image in new tab.
I'm so
and
stoked.
It's got, like, sleep token and spacey themes, and it's also got some, like, physics, and it's got some physics formula on it.
Wait, zoom in. Oh my god, that is so cool. What? Please, where can I get this? What?
So it's got my 2 favorites on it. It's got the formula for gravitation on the lapel up here. And then my other favorite is the Lagrangian, which is
Oh, yeah.
L equals. Yeah, dude, I love that shit. Okay, so the Lagrangian L equals T minus V. T is the kinetic energy in a system, and V is the potential energy in a system, and then L is this difference between the two of them. And then by monitoring L and how it changes over time, you can, it's basically another way to describe mechanics and like simple physics, and you can say a lot about a system with it, and I love it. So those are my favorites, and also my jacket that I love so much.
How did you get that? Where can I get it?
I commissioned it from this guy named High Voltage Customs, voltage with a B.
Orbeez, I need a physics jacket.
Yeah, I love it. I love it so much. It is one of my favorite things that I own.
Wait, all the Orbeez are also saying that the fit looks so cool. Oh my god, I'm so jealous.
Thank you. Rocker nerd fit. It is meant to be like a battle jacket. Like, I primarily got it because Sleep Token, but then I also wanted it to be like Super Kim VT and space themed.
Wow, that is so sick.
Thank you. Should we continue?
Yep. Next slide. Oh,
okay. This is so I'll read the question, but then I think it's gonna be more of a you thing.
Okay, cool.
So astrophysics undergraduate here. Hi, Cactus. I love astrophysics undergraduates. You fucking nerd. Do you think that neutron star mergers could provide key insights into the physics we're either missing or not understanding fully about what happens beyond the event horizon of a black hole? All I really know about neutron star mergers is the resulting elements that can happen. So yeah, this is more of a you question, I think.
Yeah, so I actually did some research about this because I needed to like seriously refresh myself. So neutron star mergers, I wouldn't say can really tell us what happens beyond the event horizon of a black hole, which is where no light can escape, but they can give us a lot of insights into gravity and the physics leading up to the formation of a black hole. So the reason why neutron star mergers have been like in the conversation recently is because we've been able to detect gravitational wave signatures for them since like 2017. And this has information about the final moments before the black hole is formed. So if you think about two neutron stars coming together, they're like rapidly orbiting one another at immensely high speeds, and then they collide, and in that collision is a giant release of gravitational waves and immense energy. And what scientists have been doing is, by measuring these gravitational waves, they have been able to better test predictions of general relativity, of the extreme physics that happens in the formation of a black hole. So one of the key insights that I think Cactus might be suggesting or maybe asking about is about the tidal forces at the event horizon of a black hole and how event horizons grow. Because neutron star mergers are sort of like the precursors to that. And so by analyzing the gamma ray bursts or the gravitational waves being released in these collisions, we can better understand how they came together and maybe even the final product, which is the black hole. So I think we're quite far from saying that neutron stars mergers could tell us something about what happens inside of a black hole. That, I think, is a really big mystery in the field of astrophysics as a whole. But they can tell us a lot about general relativity and gravity and tidal forces, all of which can get us closer to understanding what the heck happens near or even in the formation of a black hole. So I hope that answers your question, Cactus.
That's so cool. I didn't know that.
Yeah, I also didn't know that either. I had to do a little bit of research. Oh, also, apparently there's a telescope that's going to be sent out soon called the Advanced Particle Astrophysics Telescope, also called the APT. And when I first read that, I was thinking of like Rosé's song with Bruno Mars, like apatu. Like, do you know what I'm talking about? So that was what I was thinking. But this apatu telescope is going to explore neutron star mergers, which will be so fun, and there will be a song for it too, which is great.
Oh my god, that's awesome. That's so cool. Yeah, gravitational waves, this is gonna bother me until I remember what it is, so I'm asking you. Do you remember, so multi-wavelength astronomy is observing the same thing in multiple different wavelengths so that you can see, more about it that you wouldn't see in just one wavelength. And there's a word for what we do where we look at something and we look at its gravitational waves, and then we also look at it with its, pay attention to, like, its light, for example, at the same time. Mm-hmm. Do you remember what that is? I don't remember what it was.
Wait, is this the thing where you can like map the gravitational waves and it makes a chirp sound? Or is that something different?
No, it's just a matter of like...
Wait, I'm gonna Google this.
This source has emitted gravitational waves. We have detected those. Hey, astronomers, can you please point your telescope at it? Because we want to also see the light that was emitted at this time.
Oh, I don't know if there was a word for that. I thought it was just...
I thought there was.
Like, direct? No.
I could be wrong.
No, I get what you mean. It's like you feel the gravitational wave, and then wait, hold on. Let me go to the article from the 2015 gravitational wave, which I feel like was what they did for that. Like, they felt it, and then they went back to try to figure out what it was.
Mm-hmm. Yeah.
Wait, astrophysical origin. Analysis of
because
the
aside from
signal.
multi-wavelength astronomy, that's a pretty big part of the field as well, is between like electromagnetic radiation, neutrinos, and gravitational waves, taking observations in multiple different formats, mediums, basically.
The only thing I could get was like, I don't think I can't find the word for it. All I'm seeing is like follow-up observations, like...
Oh yeah, well yes, that's a good word for it, yeah.
Yeah, that's the only thing I can find on this Wikipedia page. Orbeez, if any of you guys know off the top of your head, let us know. Yeah.
Alright, ready for the next question?
Yep, next question. Oh, this is so funny.
Yeah, I leave this one to you.
So the question is, what the HE double hockey stick is dark matter from Pizza Man? You know what? I think that's the question that's through everybody's mind right now. Okay,
good. That's how I would have answered it too, but I didn't want to sound like dismissive, so I'm glad you've got the same answer.
Yeah, so I guess like I can tell you what we know right now and what we're trying to do about it. So,
oh my god, yes, please do.
So, 27% of our universe is made up of dark matter. Everything we can see and touch and feel around us is only 3%. Which is crazy. Everything we see and touch is only 3%. That means that there's so much stuff we don't know. And dark matter is one of those things. So dark matter is, we don't even know what it is. But what we do know is that it doesn't interact with the electromagnetic force, which means that it doesn't interact with light. It's invisible. But scientists can infer that dark matter exists from its gravitational effects on visible matter. For instance, we've seen this in how galaxies rotate and how galaxies interact with each other in galaxy clusters and gravitational lensing. For instance, when galaxies rotate, this can't be explained by just gravity alone. Because, yeah, I think the rotation curve
I'm pulling up a visual aid for you, yeah.
Yeah, no, this is great. I think it can feel a little scary when I first explain it, but the whole idea is the rotation of a galaxy implies that there must be some sort of additional mass or some sort of like glue sticking it together, and that is dark matter. Otherwise, the galaxies would literally fly apart. And no one knows what dark matter is made of. I think some of the leading ideas is that it is a new type of particle that interacts very weakly with normal matter. So you may have heard of WIMPs, or weakly interacting massive particles. WIMPs, yeah, WIMPs.
Yes, I love that acronym. Astronomers usually suck at naming things, but WIMPs, we did a good job with that one.
I think it's pretty sick. I think WIMPs sounds so fun.
Yeah, it's so fun.
Axions or primordial black holes, which also sounds really sick. Someone asked, what about a matter baby? I haven't heard of that. I don't know what that is.
You're supposed to say, what's a matter baby, so that it makes them feel like you're using a pet name on them and also asking them about their feelings.
Wait, Kim, I have no riz.
It's like, in undergrad, I had a friend who, when he would walk into the room, he would go, "It smells like Up Gamer in here." So then she would go, "What's up, gamer?"
No! Wait. There was somebody who used to say, like, something about, like, up dog, and you're supposed to say, like, what's up dog, or something.
Mm-hmm. Yeah, exactly. Yeah, it's like that.
Alright, well, mission failed. We'll get him next time. Next time, okay, I'll have Riz. I promise you, I'm a Rizicist. Yeah, so there's a lot of different ideas about what dark matter could be. One of the coolest things that I've heard is that these weakly interacting massive particles, these WIMPs, could be living in another world or another dimension to us known as the Hidden Valley, which is where these dark matter particles could reside. And what the Large Hadron Collider or these big particle accelerators hope to do is, by accessing these really high energy scales, like basically blasting particles at each other, they can reach into that hidden valley, grab a bit of dark matter, and bring it back, which is crazy to me that somebody could even think of that. But that's one of the theories out there, and it's really hard to test these theories because dark matter literally doesn't interact with anything. So yeah, that's dark matter. And at the end of the day, it does seem like I will need a little bit more Riz training.
Thank you for explaining it, though. You did way better than I could. Yeah, there's also, I think it's a Veritasium video. There's a Veritasium video that has a really good depiction that just uses, like, classical physics on Earth to explain why we need dark matter. Like, he's got a demo in the video that does a really good job.
Yeah, no, there's some really great videos out there explaining all of the current research being done, and there's a lot. Like, it's really spectacular what people can think of and how this search is spanning all the scales, from the subatomic particles on the quantum level to the largest galaxy clusters on the cosmological scales.
Yeah. Okay, should we continue?
Yeah. Oh, I also did want to quickly add, does that mean that there is dark energy? Yes, that is a whole other bucket of worms. We know even less about that. It just powers the expansion of the universe, and that's pretty much all we know.
Yeah. Okay, I'm gonna leave this one to you, I think. This is all you.
Yeah, so I had to do a ton of research on this one because when I first read this, I was like, what is going on? So Taco asked, based on our current understanding of physics, how might a Type 3 civilization extract energy from a rotating black hole using mechanisms such as the Penrose process or the Blandford-Znajek effect? And what challenges would they face in converting this kinetic energy into usable power on a galactic scale? So this is like a lot of jargon, so I want to just quickly break it down because when I read this question, I actually didn't know about a lot of these things. So a Type 3 civilization is a theorized type of civilization where a society could harness the energy of a galaxy. And one of the ways that this would be possible is that they could extract energy from rotating black holes. And that is one of the two mechanisms that is described here. So the Penrose process, which is in this question, uses ergospheric energy. So what that means is there is a region that is just outside of a rotating black hole's event horizon where a civilization could theoretically break down objects entering this region and send one fragment into the black hole and send the other outward with net energy gain. I think maybe there's definitely somebody more qualified in chat to potentially speak on this, and maybe Taco, if you're here or if you are watching this later, can also comment on this. But the way that this works is that it will eventually lead to positive energy. And there's a lot of challenges to this. Like, it sounds really hard because you would literally need nanosecond timing because of the incredible tidal forces near a black hole. You would need to also protect yourself from the immense radiation at or near a black hole. The second thing that is brought up in this question is the Blandford-Znajek effect, which is this idea that as a black hole rotates, the magnetic fields are twisted into these helical shapes, and this apparently generates these relativistic jets. And this idea is that a civilization could apparently capture that energy and extract that energy and use it for themselves. And there's also a bunch of challenges for that too, which is the magnetic field near a black hole is on the gigatesla scale. It's billions of times more than Earth's magnetic field. And avoiding plasma turbulence, avoiding radiation is basically impossible. So I'd say this question is really interesting to think about ways that a civilization could potentially gather energy, but you also have to keep in mind that these are very speculative and incredibly challenging. And we have seen no evidence of any civilization capturing any energy of a galaxy. So, interesting question, really cool thought experiment, and thanks for bringing up some of these concepts. So, yeah. I don't know if you want to add something, Kim, to that.
I don't have something to add, but I have a question. So the Blandford that thing effect.
Yeah.
From what you said about it, is that to say that, and I really should know this, forgive me, but is that to say that we have a reasonable understanding of where what causes the relativistic jets in a black hole?
I think it's implied that, well, relativistic jets are caused by rotating black holes. And at its core would then, well, at the center of this would then be the magnetic fields, because relativistic jets are correlated with magnetic field strength. And so the fact that magnetic fields are twisted into helical shapes as a black hole rotates is what generates relativistic jets. I think there's more to it. I feel like there definitely is more to it, definitely with how much the black hole consumes mass and matter, how fast it rotates and that kind of stuff. But I would assume that you could somehow, a civilization could somehow track the magnetic fields of a black hole and predict / capture relativistic jets. But of course this, yeah, chat, this will not be on the test, so do not worry.
I ask because I don't want to get too far into this, but I was doing a little bit of reading recently on neutron stars, and they are jets. And my understanding is that we don't actually have a very good understanding of why neutron stars have their jets at their poles.
Oh, I see. I thought it would be related to the magnetic... Oh, I guess?
It is, yeah, but, like, what is happening, magnetism aside, in relation to the matter at or on or in that neutron star that is causing that?
I see. And what's even crazier is that if you look at these jets from different perspectives, they look like they're traveling faster than the speed of light, the superliminal jets, which means faster than the speed of light. So, yeah, no, it's crazy. I actually want to do more research on this, too. I'm going to stop myself before I say something that's wrong, because I feel like I definitely need to go down, like, a Wikipedia rabbit hole on this as well. But, yeah. But I don't think all magnetic fields would make jets. See, Exalted Toast is saying...
No, not at all.
I wonder if that means that Jupiter has jets. Well, I mean, Jupiter has aurora borealises at the top of its poles, but it definitely does not have jets. And I think Jupiter is on much smaller of a scale than neutron stars and black holes, which are incredibly highly energetic products.
Magnetic fields are black magic.
Yeah, nobody knows.
They really are. I don't like magnetic fields. Okay, should we continue?
Yeah, next question. That was a hefty one. Oh, we also have another...
Okay, so...
I can read this one.
Yeah, sure.
So, Harmon Smith asked, hello, I was curious about how speed works in space. I don't know much about astronomy. Forgive me if my question's a little bit silly. Well, first off, no questions are silly. I think there's a lot of instances where you might think a question is silly, but then a lot of people have the same question. So, the question is, when planets spin, where does that energy come from, and what determines the speed of the spin? So, I actually thought this was a really amazing question, because it draws from core physics fundamentals, which is this idea of angular momentum. I can probably start off, and if you want to add, Kim. So, when the solar system came together from a rotating disk of gas and dust, the idea of conservation of angular momentum caused clumps of matter, which eventually became the planets, to inherit the total spin of the rotating protoplanetary disk. Yeah. So that is an example of a rotating disk.
I'm having fun pulling up visual aids. Keep talking.
Yeah, no, this is really cool. And And so when planets spin, that energy actually came from the formation of the system itself. So why does Earth spin? That angular momentum somehow came from the spin of the solar system, or even the disk that formed the solar system many years ago. And so that's why gas giants also spin faster, because larger planets tend to retain angular momentum better because they're harder to slow down. So that's why Jupiter rotates every 10 hours, and gas giants tend to spin faster than the smaller planets. So I thought this was a really amazing question because it really draws from those physics basis. I don't know, Kim, if you want to
I really like this question as well. I don't think it's silly at all.
Yeah.
But I don't have anything to add to that, I think. Actually, okay, I would add one thing. Due to conservation of angular momentum and how stars and their solar systems form and how they proceed to die, etc., can you think of anything at all on the macroscopic or larger scale in the universe that is not spinning? I think even if you were to lower it to any scale. Because I haven't definitively read any like literature or paper that says everything is spinning, but I personally can't think of a fucking thing.
Well, it even starts at like the spin of like well, I guess that's like more like a revolution, but there's particle spin, which particle spin is not the same as the particle actually spinning, but it is tied to the angular momentum of the particle.
Yeah.
So I'd say that is at its core an example of spin. In that case, I can't think of anything that is not technically spin. Everything is spinning, Orbeez.
Somebody said superclusters. I'm not sure. I'd have to look into that one more. Isn't it kind of down to the reference frame? Hey, the universe is technically not spinning. That's a bullshit answer, and you know it is.
Well,
okay, should we continue?
Oh, wait, there was somebody in my chat saying, hi, nice to meet you. Hello, Ichika, very nice to meet you for the first time. I came here from Japan. Oh my god, Kim is spinning! Thank you, Ichika, for the compliments. Yes, and yes, Millennium, everything is spinning, including Kim. I wish I could have a feature like that. How do I spin? I'm in a spin chair right now. Well, I guess
it's in the software I use. I can tell you more about it off stream sometime.
Yeah, I need to set this. I'm trying to spin and it's not working.
Okay. Ready to continue?
Yes. Next slide.
Cool. All right. Give Me Stuff asks, what is your favorite unanswered space/astronomy question, and what, if any, big space or astronomy questions do you think will be answered in the next 10 years? Oh, this is an ambitious question. I would like to offer to go first, but I actually don't know if I have much to say. But I can start with the first one here, if that's cool.
Wait, go ahead.
My favorite unanswered space/astronomy question, I'm into astrobiology. It is obviously most definitely the question of if/when we will ever discover extraterrestrial life, and if so, where, how advanced, etc. I'm not really a huge fan of the whole, like, just vaguely stating it as, like, are we alone question. Like, can we ask something that's a bit more of a defined question than that? That's very vague and whimsical. Like, anyway, that's very interesting to me. Aside from that, let's see. I'm gonna lose my mind if we do ever actually definitively detect dark matter, because we've been running in circles for so long.
Yeah.
But questions that I think will be answered in the next 10 years is really, really hard to say. That said, I do think that the developments in AI will introduce I think that the developments in AI have a lot of potential for the field of astronomy and, like, all of the natural sciences.
Yeah.
Do you have an answer to this?
Yeah. Well, first off, my chat is going off about, the universe might be spinning, running in circles.
Running in circles, you say, so also spinning! Yeah.
I actually said the same thing. So I was thinking, like, is there life outside of Earth? What are the base components of dark matter? I think maybe one of the questions that is more personally interesting to me is how can we consolidate our simulations of the universe with actual observations, which on the outside just seems like, oh, we just fix our simulations. But this question actually goes into like, what in our physical theories is wrong about how we perceive astrophysics and the behavior of physics on galaxy scales. So I think that those are a few questions that come to mind. I think you're right with AI and with even like large data science. Like that is becoming incredibly powerful. We are able to process so many galaxies. With the Rubin Space Telescope, I think it was like in one night, like, or it was like in 1 week, we will actually observe like, wait, hold up. I'm gonna search this up real quick.
Yeah,
it was like
the abundance of data that we have in astronomy has always been something of a it's not a bad problem to have, but like a problem. Like we have more data than we know what to do with, and I think that AI is going to be quite useful in helping us out with that.
Yeah. For instance, the Rubin Observatory is expected to survey 20 billion galaxies, and that just might sound like a number to you, but I think out of historically every single galaxy that has been observed, that's like what, like 10 times more or something like that. It's like multiple factors more than every single galaxy that we have ever seen in the universe. And we need a lot of data infrastructure to be able to process, to filter, to analyze, to identify trends in all of that data. So I think with AI, with really efficient data science, we're getting to the point where we can process that data even better and even more quickly than we can before. So yeah, that's pretty cool.
It's very exciting.
Yeah. All right, next question.
All right.
This is yours, Kim.
Oh, I love this question. Let's go. Okay. Anonymous asks, any thoughts about how people treat deep space like the depths of the ocean? I love this question. So I don't know if my answer to this is really what you were thinking of. But I free dive. I love it. I always want to go in the water. I love it so much. I free dive, and free diving means diving, but you don't have a tank. You just hold your breath, and it is so much fun.
That's scary.
And people describe it as, huh?
It's scary though, isn't it?
I don't think it's scary. People describe it as like a meditative state, actually.
Whoa.
It does put you in something of a headspace, and it's amazing. I love it so much. Part of the headspace, and I think the meditative state, is when if you're freediving, not for the purpose of sightseeing, but just for the purpose of freediving, you hold your breath, you descend 10 plus meters, etc. And then you cannot... If you're freediving in a very open space or in a space with very low visibility, you can't see a thing. It is either endless blue around you and just you and your line, or it's dark because your visibility is terrible and the water is very murky. And it's just you and this void, and you can't hear anything, and you can't smell anything, and you're not breathing, and it's amazing. You know, maybe that does sound terrifying, but I think it's amazing. And I think that there are some, like, not scientifically, but in terms of, like, artistically or in, like, a literature sort of way, comparisons that you could make between that and the void of space, and I love it so much. So I wanted to talk about that because I love going in the water, and I always want to be in the water, and I love freediving. So I really like that comparison, but, well, yeah, that's my thought on it.
Well, I'm terrified of the deep ocean because of the idea of delta P, which somebody in the chat mentioned. It's like one of my top 10 fears because there's this video called Delta P, and it's like, wait, I'm gonna put this into my chat because once you see it, like, it's so scary. It has like 9 million views.
When you freedive, freediving, the bends are pretty much not a risk at all, unless you're diving down to like 100 plus meters, because you spend so little time down there and you're not actually like taking any new breaths, etc.
Yeah.
That said, there used to be people used to think that there was a hard limit on how deep human beings could go, and I think it was around the like 30 to 60 meter estimate, because they thought that the change in pressure would cause your lungs to basically implode, like completely collapse. And then somebody dove that deep, and people have since gone far deeper than that, and now we don't really know if there's an upper limit to how deep you can dive free diving.
Oh my god. Oh.
It's so fun.
Well, this actually, I actually heard similar analogies. I don't know if you've ever heard of the Haenyeo in Jeju Island in Korea. They are basically free.
I have not.
They are a population of women. The tradition is dying out nowadays, but they have historically been free diving to retrieve like oysters and shellfish off the bottom of the ocean. They free dive without any oxygen or anything like that. Their fatality rate is quite high, but it's a tradition that's like deeply rooted in the Jeju Islands culture. I was actually watching a documentary on this. I think you might really like it. It's a really beautiful culture of women who, they're called sea women. And they basically do that. And the way that they describe it is very similar to what you described about like the sensory deprivation, the deep connection that you feel with the ocean, almost as if it's like a spiritual being. So, yeah.
It's so fun. I want to go in the water. Do you have thoughts on the comparison of deep space and deep ocean?
Probably not as profound as yours. I was thinking more like space policy because, I do a little bit of space policy on the side, just a little bit. And I was thinking that, you know, territories like the moon are considered international waters, and people like to draw analogies between international waters policy and space policy, which can be a little confusing at times because there are similarities, but there are also very big differences. So I think that is really the only thought that I have. I feel like that could be another whole bucket of worms, but I really like the way you answered that question. No, that's
super interesting. Yeah. I haven't heard, I've heard people talk about, people like to throw around the fact that we like, blah, 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 we know more about the surface of the moon than we do the depths of the oceans, blah, 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 blah. But I've never heard the, like, policy comparison, so that's interesting to hear.
Yeah, it's actually really interesting. It's a whole bucket of worms, for sure.
Yeah. Okay, should we move on?
Yep, next question.
Oh, okay, cool space missions. Okay, Gimme Stuff asks, the Karman line is at 100 kilometers, but some folks use 50 miles as the boundary of space. Who is right, and how does one... Who is right, and how does one determine such a thing? Okay. I am not really a spaceflight girly. I focus a lot more on not spaceflight. So, why don't you go ahead and start with this one?
So I can sort of speak on this. First, I did want to quickly answer Eggy's question in the chat, which was, if you give birth on the moon, what nationality is the baby? From what I recall, it would be the nationality of the person that gave birth, because, for instance, the closest policy analogy that I can think of for this is if a soccer team goes to the moon, if the United States soccer team goes to the moon and competes and something happens, then the United States is accountable for whatever happened, despite the US soccer team being on the moon and not in the US. And so similarly, I think if somebody gave birth on the moon, the person's nationality who gave birth would then be accountable for their child, and so their nationality would be the same as the child. But that's a big tangent. But
okay, so Karman line.
Okay, and then about the Karman line, both are actually correct. So I actually did some searching. So I was only familiar with the Karman line, which is 100 kilometers, 62 miles. That is the international standard. It's used by the FAI, which governs aeronautics and astronautics, because at 100 kilometers, the atmosphere is too thin for normal aircraft to be like generating lift. So at that point, space flight matters more than aeronautics. 50 miles is apparently what the United States uses. And they use this to award astronauts, and apparently they claim that from original calculations that satellites can maintain stable orbits there. I think that's a little too low, if I recall correctly, but I mean, sure. I think most people go by the Karman line. I don't think it's a matter of what's right or wrong, but rather what context you're in. If you're an astronaut getting an award, maybe the 50 miles matters more. If you are a space company trying to launch a satellite, then maybe 100 kilometers matters more. So yeah, that's my 2 cents.
It kind of sounds like the United States just trying to be different and quirky, like how we don't use the metric system.
Yeah, no, 50 miles? Like, they didn't even try to use kilometers.
No, of course it's in miles. Of course it is.
Yeah.
That's interesting, though. I really like the way that you defined the Karman line. That's very interesting. My viewers and I were recently talking about, and we probably don't have time to go on a big tangent about this, but it is interesting to think about. My viewers and I were recently talking about how defining astronauts based on whether or not they have crossed the boundary into space is becoming far less useful nowadays because commercial spaceflight is a thing.
Oh, I see. Huh. Now
Yeah.
that makes sense.
Yeah, because if we do that, then Katy Perry is an astronaut, right?
Oh my god, wait, don't even get me started on this! Oh my god, I had an over 3-hour long conversation with a group of space policy enthusiasts about this. And it's crazy because in her interview she's like, I studied string theory before the launch. Which, wow, that's really cool. I'm not sure how string theory connects with space policy, though. I don't know. I think it's okay. I think people are talking about it, which is ultimately a net good thing. People are talking about space tourism, space policy, which is great. We need that kind of stuff to be in the rhetoric.
Yeah,
it's just very funny.
Yeah.
Yeah.
Yeah. But we probably don't have time to unpack it a lot.
Yeah. Next question.
All right. Why don't you read this one?
Putting aside all basic requirements for life to exist, which planet would give us the most interesting day-to-day life? This is from Anonymous. Kim, do you want to go first?
Okay, so, sure, this is a fun question. It's just kind of a creativity question. Realistically, I think it would actually be most fun if you were completely invincible, to live on a moon of one of the gas giants or ice giants. I think that those are some of the most interesting places in our solar system. I think that would be the most fun. But if you need me to give you a planet, I think it would be hilarious to be in any of the gas or ice giants because you would just kind of constantly be whipped around by their winds. But you said you don't care about the requirements for life to exist, so you'd be alive for the whole thing?
Kind of fun. It'd be like a roller coaster, but for years.
But in terms of what would actually be interesting and exciting, I think if you were invincible and didn't have to worry about the heat, pressure, atmosphere, etc., Venus, because I hate Mars, and everybody knows Mercury is not the most exciting of the inner planets, so Venus.
Wait, Kim, you need to talk a little bit more about why you hate Mars, because I think we briefly touched up on this.
All my homies hate Mars. Yeah, I hate Mars because I think Mars is really overrated. I think we've put way too much money into it, and we should put our money elsewhere and go explore other places.
Like Europa.
Yeah, like Europa! Yes! Z gets it!
We are such Europa simps.
We are.
This is good.
Yeah. Dude, I used to have a t-shirt that had a picture of Europa on the front, and on the back it said, "Ask me about Europa," because I wanted people to ask me about it so I could info dump to them.
Oh my god, that is beautiful. I'd say, okay, I was also thinking Venus because it is literally such a crazy landscape. Pressure will destroy you in seconds. It has clouds that will suffocate you. I think other than that, I think living on Saturn would be really pretty. And I probably wouldn't think living in the clouds of Saturn, but just orbiting Saturn and just seeing those beautiful rings with the sunrise and sunset, that would be just spectacular. Yeah. Europa, our beloved, indeed. Maybe I'll go to Europa.
Europa, our beloved. Yeah. No, liking Mercury is so valid, but I think living there is just kind of I wouldn't really want to live there.
Yeah.
I feel like living on Mercury would be similar to living on Earth's moon. It would just feel very redundant everywhere you looked.
Yeah. Yeah, I mean, Mercury's pretty cool. I think, yeah, it just is kind of like a rock. It's not, there's not really much like tectonics or anything.
It is
like
a
that.
rock, yeah. Although, I do think Mercury's extreme temperatures are fun.
Yeah. Wait, sorry. I think my... Oops. Okay, wait, sorry. I think my stream disconnected for a second. Hopefully it's back now.
Okay.
Yeah.
Okay, cool. As long as you're back.
Yeah.
All right.
Next question.
Yes, next question. If you could explore... So Shifted Clock asks, if you could explore one heavenly body in the solar system besides Earth, which would it be? I feel like we've had really, really similar questions, like at least 3 of them, so I would suggest that maybe we kind of speed through this one. But assume you're immortal, can fly, don't need to eat, breathe, or sleep, etc. while you're there.
Other one we had.
Yeah. For me, so this question, unlike the other, if you could explore anywhere, where would it be? This one seems to specify that it is you in your human body. You're just gonna survive no matter what. In which case, I want to go to Europa, because I want to go in the water. No, not free dive on Neptune. Where are you gonna free dive? Where's the water? Europa.
Exactly.
There's actually, sorry, I gotta go on a quick tangent while we're talking about swimming underneath ice sheets. There is a competitive form of freediving, and this will scare you, rightfully so. I wouldn't want to do this. There is a competitive form of freediving where you try to swim as far as you can horizontally under a sheet of ice, and there are holes every meter. But the hole you come up at is where you stop.
No,
you obviously, you know, you're holding your breath, so yeah.
No.
Hold on, let me fix your audio again.
Oh, that is scary.
Yeah, it's not something that I would want to do, but it does exist. All right, continue.
Yeah.
What's your answer to this?
Oh, I'd say, I mean, heavenly body in the solar system. I think if I were to change my answer, I think it'd be kind of fun to go to the interior of the sun.
You would actually really like this article. Let me send it to you. A streamer on Twitch called Physics and Depression linked it to me. It's this super short article by this guy at IFA, Institute for Astronomy at UH Manoa, and it's called A Pint of the Sun. And it's about the intensity of nuclear reactions in our sun's core.
Oh, yes, please send that over, yeah. And if it's... Yeah, I can also probably paste it into the chat. Wait!
Yeah, I will DM it to you on Discord.
Someone in my chat says, Mom, can I go to Europa? No, we have Europa at home, and it's the European Union flag. No! You can't do that to me, Orbeez!
I expected it to be Europa at home, and it's that form of freediving.
No! Kim, you have to take me one day.
Send you the link to that, and then for the Space Squad, that link is in stream excerpts in my Discord.
Alright. Let me...
Boop. Okay, we ready to move on?
Yeah, this is actually our second to last question.
Oh my god, really? Okay, cool. So then maybe if you want, we might have time for,
some bonus ones, yeah.
Yeah, some bonus ones that are on the spreadsheet. Okay, I love this question. Do you want to read it?
Yeah. Vranus asks, what if an ice planet melted? Would the water go everywhere?
You can go first with answering it.
I
think we both can cover this one pretty similarly.
Yeah, I was thinking it would be really hard for the planet to melt in the first place because planets have rocks and rocky cores and stuff like that. Like Europa has a rocky core. I could see a liquid water forming like a global ocean with an ice shelf. Basically Europa.
Yeah.
But the other concern is that water might boil off, especially if there's little gravity to hold it down, and without like an atmosphere, the liquid water could also just sublimate, which means it goes straight from ice to vapor. So then the ice planet would literally just be a rocky core, unless something like a magnetic field or an atmosphere could retain it. I don't know, Kim, what do you think? That was what I was thinking.
If it sublimated, it'd be naked.
A naked planet?
It'd be naked! Like when you take the collar off of a dog, and then you go, you're naked! No, I think you worded it better than I could. I didn't really think of the sublimation at all, though. I didn't consider that.
Europa lives rent-free in our heads, for real. I need to make, like, or Orbeez, one of you can, like, a little photo of Kim and I side by side, and on it says, Europa simps or something like that.
Yeah. You'd think if the planet was frozen to begin with, it would freeze again, says somebody in chat. Yeah, I mean, it... Yeah, I think this question actually brings up a lot more questions about the context in which such a thing would happen. Like, does it have an atmosphere, etc., etc., etc.?
Yeah, exactly.
Solar wind would blow all the water away. What if it has a magnetic field? Etc., etc., etc.
Yeah.
Should we move on?
Yeah, I think we should. Yeah, let's move on. I also am getting, like, even more questions.
If it's entirely... Okay, well, anyway. We said we'd move on.
Yes.
Okay, Metallic's question.
Well, I guess we could also go through some of the spreadsheet ones if we have time.
Yeah, I would be happy to do that. So I've heard that both of you love talking about Pluto, so my question is, will there ever be a future in which Pluto will be in consideration for a planet again? This is a question from Metallic.
Well, you could go first, Kim, because I think I went first on the last one.
Okay. Oh, right. So Z, you're a Pluto hater. Can you actually elaborate on why, please, before I go?
Okay, okay. I don't say I hate Pluto. I just think that there are some people out there who are very convinced that Pluto will be a planet again, and I can understand why. Like, you know, like growing up, like, we learned that Pluto was a planet, and then all of a sudden it wasn't, and that's kind of jarring. But the thing is, if Pluto were to be a planet, then I think it was like there would be like 30 planets in the solar system. Like, that's really hard to keep
There'd be
track
at least 15 for sure.
Yeah, that's crazy. I read a book called How I Killed Pluto. It's by Mike Brown. Let me get the exact title. Mike Brown's How I Killed Pluto and Why It Had It Coming. It's
Mike Brown, as in the Planet 9 guy.
Yeah, as in the Planet 9 guy. But I think he wrote this before he was very much into Planet 9. Or he was he found Eris and, like, a few other, like, dwarf planets. But he details the process behind, in a memoir, the reclassification of Pluto as a dwarf planet. And I actually found this book really, really interesting. And it was actually a deeply emotional and emotive book. But after reading this, I was like, you know, we went through all this pain to, like, find all these planets, and we've had so much information that there really is only the main planets in our solar system. I think Pluto is, like, kind of the cute one, but yeah, I don't know. What do you think, Kim? Are you pro Pluto?
I think I've heard of this book, and I really should pick it up because it does sound amazing.
It is a really fun read.
I really should read it. I'm gonna keep that tab open.
Yeah.
Okay. So, hold on. Let me plug in my mic while I answer this question. It's starting to die on me.
Yeah.
Okay, so, am I pro Pluto? What a question. Like, I do not think Pluto should be a planet. I think Pluto is a fun, cute little guy. I do, like, for science and planetary science purposes, I love it. I think it's great. I think it's interesting. I think it's adorable. It's great. I love it. It's amazing. I do not think it should be a planet, and I can't stand it when people call it a planet and are like, oh, but this astronomer says it's a planet. And I'm like, no, it doesn't matter. That's not who makes that decision. Oh my God.
Yeah.
So,
you'd love the...
Will there ever be a future in which Pluto will be considered a planet again? I would pretty confidently say no.
Yep. I'm on the same page. Hopefully,
so that's...
The Orbeez are gonna start unsubscribing. I'm sorry.
That's... One of my viewers also said unfollow.
No!
Pluto is not a planet. And also, oh my god, like, oh my god, where do I even start with this? Okay, sometimes I will hear people who were born in or after 2003 talk about how Pluto is a planet. And I'm like, it was literally, your whole life it has not been a planet. And like, oh my god. And part of that I think is to blame on science, like elementary school science teachers that are incapable of moving on, right? But like,
Yeah.
oh my god. Yeah, so
Oh my god. Okay, this is very polarizing. Some of my chats like we'll go on strike, and the others like I'm here for the Pluto slander. So you know we're gonna get unfollowed, and then we're gonna get like a ton of random support. We're gonna get some follows too. So it's net zero.
yeah, like I'm not anti-Pluto. I just it's not a planet.
Yeah. All my fellas like Ceres though. Yeah, I think Ceres is pretty cool.
Ceres is good, yeah. Okay, should we would you like to look at some of the ones on the spreadsheet?
Yeah. Oh my god, we got almost 92 questions. What?
Here, let me
I've not checked the spreadsheet since like a few days ago.
wait, we're at 90? Last I checked we were at 65. Oh my
We
god.
are
Okay,
at
so full
92
disclosure
questions,
guys,
Orbeez.
we are biased, like focusing more on the questions that were submitted earlier. We're kind of going somewhat in order. Here, wait, let me pull up some like filler content on my monitor here. I know what filler content to pull up. Let me pull up the picture that I made for our collab, and that way we have something here while I also pull up the spreadsheet.
Yeah, I highlighted in blue where I think is where we stopped.
Okay, perfect.
Well, oh, actually some of these we've already answered. Actually never mind. I just lied. I guess
Let me see. Yeah, and also since we can see each other's highlights, that makes it very easy to be like, hey, what do you think we should answer next? How about this one without reading it out loud? Okay, yeah, let me look at this. So,
yeah, I'm going through these ones.
Oh, okay. Can I answer this one?
Yeah, go ahead.
I love this question. I love this question. Zolly asks, why do you do this to yourselves? This being joining academia. Real. This is a very real question. My answer is that I love space. That's it. That's my answer.
Wait, maybe I need also a filler screen. I guess, like, for me, also Loki, space is kind of sick, like...
Yeah!
Oh, here we go.
You thought the answer would be because I'm a masochist. Well, I also just love space.
Here, let me put this in the back.
And like, I also, like, astronomy is a field that, if you are an astronomy major and then you pursue the field of astronomy beyond your undergrad and want it to be your full career, you kind of have to like research. And I do like research, so that's good.
I think also what's really cool about space is that it's really the biggest scale that you can think of, right? Like, cosmological questions are like the biggest questions, period. And I think that is what is, I think when people ask me like why astrophysics, like that is really the core of why. So yeah.
yeah. Some people ask me like why astronomy over other fields of science, and my answer is fairly similar to that. Yeah, that it's about this.
Also nowadays with so much space exploration, we're basically in a second space age, which means that there's a lot of shared excitement for space, but B, also a lot of necessary conversations we need to have about space policy, about how we're getting there, about how to, you know, treat space sustainably and so forth. And I think all of those questions can also be answered by, you know, by looking into space and having some advice from there. So I'd say, yeah, this was a cool question. Well, I wouldn't say it was cool, it was kind of a fun question.
It's a hilarious question. It's so real.
Yeah, I also like this other one you're highlighting, if you want to...
Okay, good, because I love this question. I think we should both answer this one.
Yeah.
Do you want to read it?
Yeah. So the question is from... Here, let me actually see if I can put it into this box. So the question is, what does the process of astronomy versus astrophysics research look like? What would you say to... as a field known to be open to amateurs... what would you say to an amateur astronomer who is looking into going into professional academia? Kim, do you want to start on this one? I'm just gonna put the question in the bottom real quick.
Sure, I can start. The process of research is, I think, notoriously difficult to describe rather than just doing it. To shorten it, the process of research is you have a question and you take the steps to try to answer it yourself, as opposed to simply Googling it. In astronomy and astrophysics, what that often looks like, what it has looked like for me, etc., is you have some data that you have identified probably from the start that you're going to work with. Could be data that you had taken or took yourself, or it could be archival data. It could be telescope observations, or it could be, I don't know, something else if you work with like gravitational waves or something like that.
Mm-hmm.
If it's telescope observations, it could be images, or it could be spectra, and then there's a process of reducing that data. Reducing that data means taking the raw data, which is generally very, very messy, and turning it into something more comprehensible. So if you're looking at an image, that means like if you're presenting it to like the public or want, or like for outreach or something, it could mean adding color. It could mean adjusting the, oh my god, why am I blanking on the name? Why am I blanking on the name? I've done this so many times before. I'll describe it and maybe you can remember what it's called.
What is it?
When we have images in astronomy, our detectors are so sensitive to different amounts of light that we have more than we have grayscale pixels on a monitor. So we adjust the fit of those ranges of light to the color range on our monitor. And it can be like a logarithmic scale, or it can be like a Gaussian, or something like that. And then doing that, we can see different things in the image. What's it? I forgot what it's called!
I genuinely don't think I've interfaced with this before, actually. Maybe it's because I don't do observational. Someone says gamma?
No, it's not super sampling. It's, I literally forgot what it's called.
I don't know.
Wavelets? No, I literally forgot what it's called. But that's what the process is. That's part of it. And then sometimes your research may also involve working with like catalogs and large data sets that involve a fair amount of organization. And by organization, I mean automation. Modern day astronomy, oftentimes your research boils down to a lot of programming, which I think is great and fun. Deconvolution? No. I don't remember what it's called.
Yeah, no, I'm not sure either.
AstroPy, my beloved. AstroPy, my beloved. Yes.
AstroPy is so fire. Let's freaking go. Python is great.
Yes. This is an AstroPy appreciation post.
AstroPy Sims.
Yeah, so it's a lot of programming, and then once you have done all of your research work, you start writing a paper. And writing the paper, sometimes writing the actual paper can be the longest part of the process.
Yeah, that can be true.
Yeah, it's a lot of work. It's a lot of jargon. It's a lot of how do we... I gotta be honest, this might be a little bit of a hot take, but I gotta be honest, I think part of writing a paper is a fair amount of how do I word this in the most elitist, littered with jargon, inaccessible way that I possibly can.
Oh my god. Wait, I feel like fortunately for me, a lot of papers that I've encountered, people tend to be more humble / accessible.
Oh, you're so lucky.
Yeah, maybe I've just been lucky. Who knows? Maybe next week I'll just be like, oh, I've had a really bad experience with this paper, but... Yeah.
Okay, somebody asked what's AstroPy. AstroPy is a Python library that is full of a lot of tools that are super useful for astronomical data reduction.
Yeah. I was wondering...
I know that there's a reason that we use jargon, but there are times when it's excessive. Like, I was reading a paper that used the word contemporaneously instead of just saying at the same time. Yeah, like that sort of thing.
Okay, that's a little pretentious.
Yeah, that sort of thing. Okay, and then what's your answer to this question?
I'd say since you've basically answered the first question, I'd say like for the second question, the honest truth, if you are an amateur astronomer who's looking to go into professional academia, the honest truth is that academia is really based off of like postdocs, PhDs, like higher level education. That being said, that should not stop you from, if you want to pick up university again, or if you're in university continuing onto the academia track. It is a long process, but it is very rewarding. You feel like you've gained a lot of skills and etc. But if you are somebody who is not planning to get a PhD, is not planning to go into higher education, it is quite tough to break into professional academia, but there are still a lot of ways you can contribute. For instance, now with the internet, citizen science is more accessible than ever before. And I've heard of instances where people have made like AI models, like literal like kids straight out of high school made like a crazy AI model to sort through like exoplanet data. And this individual clearly did not need a postdoc or PhD to do that. So there's a lot of ways to get involved. I'd also say if you want to help out with citizen science surveys, I know that the variable star community and the exoplanet community are always looking for ways to gather more observations, because when you look at an object, you can't immediately tell if it's like an exoplanet or a variable star. You need to gather observations over months and have multiple confirmations. And if you are a telescope that is in very high demand, that is impossible to access. And that's where, you know, amateur telescopes can come in. And if you have a telescope, that might be a way you can contribute some data to help confirm that an exoplanet is actually real, or the period of a variable star and so forth. So I'd say don't lose hope. It's pretty tough to go to professional academia, but there are still so many ways to help. And Warpy asks, AI models by citizens like Vedal. I know who you're talking about, the Neurosama guy. Well, Neurosama is like an instance of like a streamer, right? But I've also seen instances of like AI models to sort through high quantities of data, because a lot of telescope data ends up being public eventually. And there, in many cases, are things that scientists have missed. And that's what you can look at. So, yeah. I think that's basically my take on this.
That's a really good take. That's a lot more than I would say on the matter. Astronomy, I would add one thing though. Astronomy is like, as this, how exactly did they word it? As a field known to be open to amateurs. So when I first read that, I was like, it is, but what this person is talking about is amateur astronomy, which is like the backyard astronomy, the setting up a telescope, the astrophotography, that sort of thing, which is like, we have a specific term for that. It is amateur astronomy. And I do want to emphasize that amateur astronomy and professional astronomy are really different tracks, actually. They're both astronomy. We are united by a love for space, but they don't always get along. So crossing over between the two might not be as smooth of a path as you might hope. I think that the skills between the two might not be as cross-applicable as one might hope, but I think that Z gave you some really good resources to go to for it.
Yeah. Wait, Kim, I actually had a follow-up question. Do you think that nowadays, with people getting access to really nice digital, like, very smart telescopes, how do you think that will change observational astronomy? Like, do you think people can contribute their smart telescope observations and make a really big difference in the data that we're collecting?
Okay, can I use this question as a segue into what Zali has been like nearly begging us to talk about?
yeah, sure.
So
wait,
on
I'm
the
curious.
relation of telescopes getting better and backyard astronomy, Zali directed Z and I to this project, Wow at Home, which is, I only got the chance to skim it. I really only got the chance to skim it. A network of small radio telescopes. Low cost, blah, 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 blah. I think it's a matter of like, would you like to set one up at home? This is the scale that we're talking about. And, let's see.
Oh, I'm
Dude, this is so many words.
Yeah.
I'm sorry, what'd you say?
I'm looking through it right now, actually. Just skimming over it.
Yeah. Let me know what you find, because I admittedly did not read this entire thing.
Wait, there's one thing that does come to mind when I read this. So there is a network of, it's called TinyGS. This is what some amateur satellite people use. It's a network of radio stations all around the world, and they communicate with satellites that pass over it. And I think that's a really good instance of where citizen science can help contribute, because a satellite, when it's on the opposite side of the planet, will not be able to communicate to somebody in the US, for instance. But if there is somebody on that little citizen science tiny GS network that spots the satellite, then they could notify the network and be like, oh my god, I see your satellite, it's passing over Asia right now. So I think that's a really good instance of where I've seen citizen science at work. And this immediately came to mind because I saw it was a network of small radio telescopes, so I was thinking maybe that's what it's trying to go for. I'm not sure. I don't know, Kim, if you have some thoughts too.
While I have this website up on my main monitor, let me also... You're seeing the WoW at home on my Discord screen share, right?
Actually, let me... Oop.
If you're not sharing it anymore, then that is also totally fine.
I think, I think I've lost the screen share. Where did it go? Oop.
I was gonna say, citizen science is very, very powerful. It's a super useful tool. Let me answer this a little bit more in the context of specifically, like, the specific wording of Zali's question, as opposed to trying to rapidly understand this entire website. Which the question is, do you think large amounts of bad to mediocre data and the appropriate computer algorithms could produce data comparable to the EHT? Why or why not? It's worked in other fields. So kind of like what Z was saying, big vouch for citizen science. That's great. I love it. I have heard of not exactly backyard scale, but somewhat similar projects to this that are like, set up this fairly low tech antenna and we're just going to get a lot of data, even if it's not that great, and we should be able to work with it. I think JCMT did something similar. At one point, we had this like maybe like 5-meter diameter antenna set up in Hilo outside of our building, and it was, I think, for a project that was not that we were just partaking in. I think they just like sent us this antenna and we were like, yeah, sure, we'll set it up for you and you can take the data and whatever. I think, but I wasn't involved in the project. I only heard like whisperings of it at meetings. That said, this sounds exciting. Crowdsourced astronomy, yay. Networks of telescopes, although this specifically isn't interferometry, but still, yay. Sounds interesting, sounds promising. However, I think that there's a limit to it.
Yeah.
So my concern is that Zali specifically mentions this as, could it ever be comparable to the EHT? Which, here's my concern. EHT's data is already so much data and so messy and takes them like minimum 2 years to reduce from when they collect it. You're telling me you want to do that with even messier data? I feel like there's going to be a point where it's just not worth it, is my concern.
Yeah, I get what you mean. Yeah. Yeah. So
maybe tell people what EHT stands for. Have I never said what EHT stands for?
I like totally may have also missed that too.
EHT is the Event Horizon Telescope. They are responsible for the first ever image of a black hole. You may recall that it went somewhat viral when it was released in April 2019. Last I spoke to their outreach person, they had estimated that around the world about 3 billion people have seen that image. And that image in question is Povecchi, the supermassive black hole at the center of M87, and it's also my eyes on my Vtuber model.
Oh, I was like, whoa, you like zoomed in. Oh, wow, that is so cool. Did you design your model yourself? Yeah, I just tinted it
purple, and it's my eyes.
Wow.
So now when I talk about Povecchi, the supermassive black hole at the center of M87, I'm like, here, look, this is what it is.
Wait, Chad, someone needs to clip that, or I'm gonna clip it. It's like a giant eye on my screen. Oh my god, I froze. It was that good. It was that good. Wait,
did you have, let's see, did you have any further takes on this? I would like to read a little bit more about this.
Give me one
sec. It sounds like, at a glance, it sounds promising, and it sounds interesting. It also sounds perhaps a little bit ambitious, but also, that's not to say that there's problems with being ambitious. That's kind of how we get shit done.
Yeah, I think I think at the end of the day, one of the really cool things about citizen science is that it is bringing science to people. And I think, you know, if you can think that science isn't this thing that only PhD students can do and is so far-fetched from the ordinary person, then I'd say that's a net positive. I think there are ways for people to get involved in citizen science that can make science seem more exciting and accessible. But I think, yeah, I think there are some limitations, and I think if you do want to get involved in citizen science, it is also good to be aware of, like, which projects you want to contribute in and what you want your sort of impact to be in. But of course, no pressure. Like, I feel like maybe one of the things that can sort of come across in this conversation is like, oh my god, you need to like contribute so much, but that is not the case. It can just be as fun. Yeah.
As a scientist is that you don't have to contribute so much.
Yeah.
Like, you can kind of just do as much as you want.
Yeah. Yeah, no, exactly. No, this is a great question, though.
We actually, you said you have a 2-hour cutoff, right? So we have, like, almost no time left. Is there any other questions that you'd like to go over real quick before we...
Yeah, we should wrap up soon. Yeah, Orbeez, it's my friend's birthday tonight, so I gotta go and celebrate, which is gonna be a lot of fun. Oh yeah, for Kim, do you like tardigrades? This is a very important question.
Yeah, I think they're cute and fun and badass.
Kim, we can no longer speak to one another anymore.
Why? You don't like tardigrades?
I'm scared of tardigrades! So, you know Phi the neutrophil?
Did you say you're scared of them?
Yeah, they're so creepy looking!
You know that if there was one sitting on your fingertip, you literally, like, wouldn't even be able to see it.
You know what's even creepier is that there's probably, like, a quadrillion of them on my face right now. No, I'm terrified of them. So, Phi the neutrophil, who is in Vtuber, like, gave a collab with me, a talk about tardigrades and how they're cool, and I thought it was really cool, but they're still really creepy looking, so, yeah.
Wait, I really hope this is a joke, because otherwise I'm gonna feel terrible for laughing, because it's a really funny one. Somebody in my chat goes, what kind of an orbit is a tardigrade?
No!
So good!
It's so good!
I love it. I'm stealing that.
Wait, I'm gonna steal that from now on. Whenever somebody asks if someone likes tardigrades, I'll just be like, what do you mean? What do you mean, the orbit?
Mercury's in tardigrade or whatever.
Yeah, Mercury's in tardigrade.
Oh my god!
Oh, this is great. Oh my god.
Oh my god, Z, I had such a good time tonight. This was awesome.
Yeah, no, this was so much fun. I feel like this is like the first like Astro Nerds collab. Like, I like love that there's like a streaming community with like fellow astrophysics nerds, and yeah, it's so cool what you're doing.
I also, like, I've done nerd collabs, but I've never done an astronomy collab, so this was amazing, and I am so happy we got to do this. And I am so happy that I got to meet all of your Orbeez, and that I could share you with my space squad.
Yeah, hello. Well, thank you so much, Space Squad, for having me. And yeah, no, this was so much fun. I absolutely love this. This gave like Star Talk vibes. I really enjoyed it. And Orbeez and Space Squad, I hope you guys did too. So yeah, and if you have any questions that we did not get to, which apparently there were like 40 of them that we didn't get to.
Oh my god, there's so many.
Like, please do not hesitate to, you know, drop them into, well, I'll send you my Discord in my chat. And also, if you haven't already, go follow Kim's Twitch, which is in the pinned comment in my YouTube channel. She does really, really amazing content. I've also seen, like, your cooking streams, which are so much fun.
Oh my god, you shouldn't. They're so bad. Thank you. Yeah, and I have put the collab command in my chat so that everybody can also go see you. And also, what's amazing about Z is that, see, I don't have the attention span for this anymore, or at least not lately. But Z makes, like, not just streams on YouTube, but also actually like posts long-form YouTube educational content, which I try to do, but Z's way better at it than I am.
Oh no! Yeah, no, I've been making my partial differential equations course/series, which has been a lot of fun, and yeah, and YouTube Shorts.
I'm gonna watch that.
Yeah.
Yeah.
Woohoo. Well, I I really enjoyed this collab. Thank you so much for making this possible. This was a lot of fun, and yeah.
Thank you so much as well. I appreciate all the work you put in, and this was so fun, and I'm really happy you reached out to me to do this, and it was great.
Yay! Well, thank you so much. Well, everybody have a good night, or good morning, or good afternoon, wherever you're from, and we shall see you guys in the next one. Bye-bye!
See you later, Z.
Bye-bye! Bye-bye. I'm gonna hopefully click the right screen. Okay, bye!